Okay, let's take a look now at the secant curve. All right, so here's the chart. Remember that secant comes from cosine. So what we're going to do is we're going to go graph a cosine graph first and then flip it and make it become the secant. So here is the equation that we're going to graph. On this one, we're going to sketch a negative cosine because our a value has the negative in front of it. So make sure we do that, pay attention to that. Okay. So let's set up our axes. We're going to move to the right. So, whoops. It's amazing how many different colors I use, and then it never gives me the one I want. There is a 0 for a vertical shift. We're going to add that to 3. So we're going to need to go up 3 units. But because we're graphing secant cosecant, we want to be higher than that. So actually, I'm going to graph up to 5. It gives me a little bit of room above the cosine curve so I can get the secant in there. So it's 5, 4, 3, 2, 1. Here is the x-axis. Go a little bit more. We have an amplitude of 3, so I'm going to be off this graph a little bit. It's going to be a really big graph. So that's, I got to go down about here and about to there. 1, 2, 3, 4. We'll go down one more. We'll call that -5. This is -5 right there. So I actually got to do my x-axis. I forgot to do that on the last one. I'm sure you guys are all yelling at me. Coach, get your x-axis done. There's... Okay. Let's see. Just write in a couple things here. Here's pi. Here's 2 pi. Here's 1. Here's -1. So -1, -2, -3, -4, and yeah, -5 is down there at the bottom. All right. So it's going to be a pretty big graph. All right, let's check out where we're going to start. Move this up to the top, give us a little bit more room. All right, so 2 theta minus 3 pi equals 0. So manipulation of that is going to tell us that theta equals 3 pi divided by 2. So that is way, I actually probably should have done my ceiling and my floor. So let me throw those up there real quick because you guys are probably yelling at me. Do your ceiling and your floor. So there's my ceiling. 1, 2, 3 floors about right there. So now you guys can stop yelling at me. All right. So we're going to start. We're starting our graph here, right? 3 pi over 2. 3 pi over 2 is halfway between pi and 2 pi. That would be right there. So I've got to kind of make that a little bit bigger. Just a little bit. Get that down to there. Make it a little taller. There we go. So that's where we're starting. That's 3 pi over 2. We will go and now do the endpoint. 2 theta minus 3 pi equals 2 pi. So 3 pi plus 2 pi is 5 pi. 2 theta equals 5 pi. Theta equals 5 pi over 2. Now, for those of you good at math, that's 2.5 pi. So here's 2 pi. So 2.5 pi is going to be right here. So that's where we're starting. It's not actually a very wide graph. It's just tall and move over to the right. So we're going to finish this up. We're going to have our phase shift, our period, just takes us to right there. So if you want to see where we're going to be, we're actually going to be right in here. That's where we're putting a cosine curve. Not just a cosine curve, but a negative cosine curve. So a cosine curve starts at a negative one, is going to start at the floor. It's going to end at the floor. In the middle, it's going to be at the ceiling. And then the midline points take over. So those are the 5 points. We'll connect those, make it a cosine. But remember that the cosine is not actually what we're trying to graph here. We're trying to graph a secant curve. So let's see what happens now that we have the cosine version. Let's go back and check out the chart. So we have our 1 turns into a ceiling point. The 0, remember it's the zeros that are really important. It's not really this 1 point up here. It's the 0 point. The 0 point is what you're really interested in. The zeros, the midlines, are going to become undefined. Those are your asymptotes. So let's go graph our asymptotes real quick. Find the midline points. Those are going to become asymptotes. Not that one, this one. We'll make it red. Red. So asymptotes at the midlines. Move that over just a smidge. There we go. Get another one. An asymptote through the midline. And we get that again. We get that from this chart over here on cosine. Right here. Right here. And I know that doesn't really help you much, but right here, this is what we're talking about. This is the chart we're using. So we have our asymptotes. So we graphed a negative cosine, we graphed our asymptotes, and now we're here. We're going to flip the curves outside the box. So we do these little parabolic curves that are outside the box, starting at the points and heading towards the asymptote. So these two down at the bottom, very much like the tangent curves we did on Tuesday. So big picture here. That is what a cosecant, that's what a secant curve will look like. And so that is number 2. That's your secant example. So let me talk a little bit about the homework. This is worksheet 6. View it back to 150. So this is worksheet 6, and there are only 6 problems. There's actually going to be 12 things you're going to graph. So just a quick sketch here. Quick sketch. This is quick sketch. This is not going to be what you're going to do. Oh, I see there's a difference. Well, what I want you guys to do is actually graph the cosecant curve, not necessarily the sine curve. So I'm not interested in the sine curves. I'm only interested in the secants and the cosecants. So we're going to graph this one right here. So you're going to do, and this is not the answer, I'm just making this up. You're going to graph the sine version. You're going to come in. You're going to give me some asymptotes. And then you're going to come and give me the secant or the cosecant, depending on if it's a sine or a cosine. So that's what you're trying to do here on worksheet 6. So you're going to have to graph the sine and cosine version and then create the secant and cosecant from it. Okay? Well, I wish you guys luck. Don't forget, you have 34 graphs due tonight. You're doing worksheet 6. You're only going to do the secant cosecant version, which would be the right-hand side of each problem. So don't do just the regular sine cosine. Do the cosecant secant version, which you're going to have to do sine and cosine within it. Good luck, guys. Have a great day.